Hi all, and welcome to this talk called TeamCity and the Kotlin DSL, from zero to hero. And as David said, I'm Marco Behler. I'm the new developer advocate for TeamCity at JetBrains. And this talk is all about how to create your build configurations, your build pipelines in TeamCity with Kotlin code instead of using the UI. And we're not just going to cover the basics like how to get started with Kotlin DSL. We're also going to have a look at some of the more intermediate and advanced concepts. And I could basically spam you with abstract slides telling you how good it is to have a statically typed language like Kotlin with superb IDE support and IntelliJ IDEA and whatnot, and how much makes sense to use it for your build configurations. But I'd rather have you see the Kotlin DSL live in action and then judge for yourself by the end after now 50 or 55 minutes of live coding / live configuration, if you like it or not. I think that's enough as a start. And enough, we can get started. Right. Now, what I did is I prepared for this talk a small sample application. It's a to-do list application. It's written in Java with the Spring Boot framework. And it actually doesn't matter too much what the application itself is doing. What matters more is the project structure for our build chain later on. So we're going to have a quick look at the project setup. And as you can see, I have the project checked out. It's called a new to-do list. It has a POM XML file, so it's a Maven project. And then you see the default Maven directory layout, source main Java, and resources with the Java classes and HTML templates that make up the application. And then a bit more interesting, we have a test folder with 2 packages, an integration package and a unit package containing, well, integration and unit tests respectively. More specifically, there's one slow web service test, which takes about 5 to 10 seconds to run because it connects an external web service. And there's a unit test, which is pretty instantaneous. And it's good to know about these 2 tests for our build pipeline that we're going to build in a second. But before we start writing Kotlin code, I actually want to go through setting up a build pipeline for this project in TeamCity with the UI first, so we're all on the same page with the same terminology and whatnot. So what I have is I have my TeamCity server, and it's completely empty at the moment. I'll just start by creating a new project from scratch, completely from scratch. I'm going to paste in my repository URL. What you can actually do, now it's on GitHub, Marco Behler JetBrains, a new to-do list. You can fork and clone the repository and do exactly the same steps I'm doing here for this presentation. And then what you want to do is you want to give TeamCity write access to your repository. Why? Because when you enable Kotlin code later on, TeamCity needs to commit to your repository from time to time, hence you need write access. And I'll tell you when that is in a second. So I'm just going to paste in my access token here, click proceed. It's going to take me a second. TeamCity is trying to connect to GitHub, right? And then I can see, well, the connection was successful. The project name could be a new to-do list for now with one build configuration called build. I'm just going to go with the defaults. That's all fine and good. And then TeamCity does its magic. It scans the VCS repository. It finds a POM XML file and says, well, if you have a POM XML file, I recommend you to have a build step called Maven, executing the goals clean test, essentially running the 2 tests you saw just a minute ago. And I'm going to go with the defaults for now. Right, and we have that build step. Now, I can already trigger build, so I'm just going to click run here. And it brings me to the overview page. TeamCity, the build agent is running. It's starting the build. While that is happening, I just want to go back to my configuration page. I'm just, as I mentioned before, want to quickly go through the terminology. we're here on the project level, a new to-do list inside the build configuration. We just have one configuration, which is called build. And here on the left, you can see you have version control settings pointing to the GitHub repository, Marco Bieler JetBrains, a new to-do list, which is by default polled every 60 seconds. For this demonstration here, I put it down the checking interval to 5 seconds, but there's polling involved. And then you have a corresponding VCS trigger with a branch filter set to star, which means that every commit you make to any branch in your repository will trigger a build. So we have version control settings, the triggers. And last but not least, we have our build step, our Maven build step, which runs clean test. Again, it just runs those 2 tests we saw earlier. And now, when I go to the project overview page, that was already enough. So I can see my build worked, test passed 2, just as I expected it to be. I can even have a look. Slow web service test here says it took me 5 seconds, right? And the syntax check unit test took me less than 1 millisecond. Right. Now we have that as a starting point. We have a very simple project configured in TeamCity. Now the question is, how do we turn that project configuration that we just did into Kotlin code? And again, you're not going to start out by writing Kotlin code immediately. Rather, you're going through the UI at the very beginning, at least. So what you can do is, again, make sure to go to the project level now, not inside the build configuration, but on the project level. And you'll find a link here, which is called version settings. Why do we need to go to version settings? Because your Kotlin code is also going to live in a VCS root. So in this case, in my GitHub repository, it's being versioned. Hence, you need to enable version settings. And you have some options here, simply saying, well, please enable synchronization. And then TeamCity prompts you to choose a VCS root. I'm going to choose my a new to-do list repository, meaning my Kotlin code is going to live in the same repository. It could also live in a completely separate repository. And we're going to have a look at that at the end of this talk, actually. So I'm just going to go with that. I have a couple of options here. And usually what I want to do is whenever a build starts, it should use the latest settings from the VCS, from my checked in Kotlin code. So I'm going to go with that. And you could use the upper options if, for example, your Kotlin code was broken and you wanted to override these settings from the TeamCity server UI. But as a default, just go with the VCS settings. And then down here, you can see you have 2 different settings formats. An XML was the default. You want to choose Kotlin. And just a quick note, the Kotlin code you're writing actually generates those XML files behind the scenes for you, right? And you have Kotlin code. And I think before TeamCity Server 2018, there was a different way of writing these Kotlin scripts, and they're called non-portable. And if you're writing Kotlin scripts for new TeamCity Server versions, you always want to go with these portable DSL scripts. Right. A lot of talking. You can finally hit apply. And then you'll see a new section pop up down here, the current status. Now, TeamCity is going through your build configuration, the one we just created, a new to-do list with that one build step, running through it, and then actually creating Kotlin code and committing the Kotlin code to your repository. So you can see that message here, successfully committed revision. Right. Let's have a look at what TeamCity actually committed. Which means I'm going back to my IDE. I'm just doing a pull. It takes a second to finish. And then I get a message saying 2 files updated in 1 commit. I have a new TeamCity folder up here in my project with just 2 files, a POM XML file and a settings KTS file. Inside my settings KTS file, there's my Kotlin code. And the POM XML file means this folder is also a Maven project, but it is not related to your a new to-do list project in any way. It's a completely separate Maven project, which means you actually need to add it as Maven project Otherwise, IntelliJ IDEA will not pick it up automatically, right? So this is just one tiny thing to keep in mind. What you also can do while you're at it, I like to download sources and documentation later on, so I can actually go through the Kotlin DSL and have source code available, documentation, right? But you want to make sure to add the POM XML file as a Maven project. You can see IntelliJ is working, downloading dependencies, and after a while, these icons will change, and you will see that IntelliJ now recognizes the thing right now as a module, which means you get auto-completion, and that's what you want. Inside your POM XML file, also inside your Kotlin file. The POM XML file doesn't matter too much for now. Let's have a look at the settings KTS file, the Kotlin code for your project on the TeamCity server. Now, at the top, you have a version flag saying what version generated that Kotlin script file, 2020.1. Doesn't matter too much for now. But up next, you can see I have a project block. Inside the project block, I call a method calling build type, and I'm referencing a singleton object down here called build. Now, what's a build type? Essentially, build type in Kotlin DSL is the same thing as a build configuration in the UI. So it's just two different names, one for the Kotlin DSL build type and build configuration in the UI. So I'm essentially saying my project has one build type / build configuration referencing the object build. And when you look at the build object, you'll see you have a name flag build. That's what you see in the UI. You have your VCS root that we just had a look at with a shorthand set to DSL context settings root, which means the VCS root for your project, for your new to-do list project, is the same as the one where your settings KTS file lives in. So you don't have to specify the URL manually. Then you have a step, one Maven step. We had that already, Maven goals clean test. Simply running the tests. Runner arguments, Maven-specific runner arguments, which basically Maven by default stops whenever it finds the first failed test. And in a CI system, you just want to collect statistics of all the failed tests, so you have that flag here, right? Maven step. And then last but not least, we have a default VCS trigger, which simply means every commit to every branch will result in a build. And that is what a very simple Kotlin file looks like, describing your project on the TeamCity server. Now, we have that file. Let's actually try it out. What happens if we make a very simple change, and if instead of calling Maven clean test down here, we just say, well, I want to call Maven clean package, and then we're just going to go commit and push this change. And we're going to have a look at what happens on the TeamCity server side now. So I just committed. The push succeeded. Let's go back to the TeamCity server. Now, as mentioned before, I decreased the polling interval to 5 seconds so we can actually see stuff faster here. Otherwise, we'd have to wait 60 seconds for something to happen. But down here, you always see the current status. So running DSL means TeamCity already fetched the latest Kotlin script version. It's running through the DSL, through the Kotlin code, generating those XML files. And what I'm actually going to do is I'm going to keep that tab open here, right? And I'm just quickly going to open up another tab with the configuration open, so I can switch easily between these two. Again, I'm in the a new to-do list build configuration, build step Maven. And as you can see down here already, TeamCity updated itself. The goal now doesn't say clean test anymore. The goal says clean package. So after the polling, after the latest polling, TeamCity saw, well, we changed something in the Kotlin script file, and it updated itself. That was rather simple and quite cool, but it was a very simple change. So what we did is we just modified a Maven goal here from an existing block. What happens if you want to add, say, new build features? Everything that you can basically do in the UI, you can also do in the Kotlin script, but where would you start? And you might be thinking, well, it's Kotlin, and I have auto-completion going on in my IDE, so I can just go inside the build type here, for example, wait a second, and then have like a pause flag, template, a create method, an ID method, and whatnot. I could step inside my VCS block, and I'd find a branch filter. And I could, as I mentioned before, you can have the documentation up for all these variables. Defines a branch filter to be used for branches coming from snapshot dependencies, for example. You could go inside your Maven build step. Here you'll even find options for Docker pull, Docker image platform, Docker image, POM location, right? But at the beginning, when you're not used to writing your Kotlin code, that's not how you start out, just hitting autocomplete and then go through the documentation, hope that everything is going to be fine. Rather, there's an easier, simpler way to, well, ease you into writing this Kotlin code. And again, it starts with the UI, actually. So let's go back. And imagine let's edit that build step again. And you have that dialog window popping up. You have a ton of different options. So for example, you could say, well, this build step should have a custom step name. Let's call the build step Marco step. You want to maybe call Maven clean test again. For whatever reason, you want to set the Maven version to 3.4.354, right? You also set the JDK version to JDK 14. And if you wanted to, you could also specify a Docker container image here, right? Now, what would these options look like in Kotlin code? That is the big question. And as you can see, TeamCity here at the bottom says the changes are not yet saved. Click Save. But I don't want to click Save for now. Rather, I want to scroll up again. And on the left, you find a button which is called View DSL. Click this button. And what you'll see is that a dynamic view of your settings KTS file opens up. Here is your build object, the one you just saw in the IDE, with your name, with your VCS root, with your Maven step, and then with all the options that you just clicked and selected in the UI as Kotlin code. So you can just select this block here, the Maven block, copy and paste it, do not click Save, and then go back to your IDE and just override whatever there is at the moment. That's how you would set Maven version. You would call a method bundle3_5, JDK home and whatnot. That's how the Kotlin code would look like. Now, that was for an existing Maven step. Can we do the same thing for completely new blocks as well? Yes, we can. So again, when you go back, for example, think about, actually, let's change one existing block before that as well. Let's change the VCS trigger. Here you can see you have the branch filter set to star. And when you click Edit, then you'll have a new dialog window pop up. And you cannot click that View DSL button here on the left anymore. I'll show you how to do it in a second. But first, let's click some random options. The options themselves don't matter too much for at the moment. It's just some random options. So I'm going to go with a quiet period of 30 seconds, trigger build on each check-in, right? And then you'll find on the dialog window, you'll find a View DSL button. You click that, and then again, you get the Kotlin code corresponding to your options. Do not click Save anywhere in that process. Just go and view DSL. Now we're going to copy that, and you can see you're in the triggers, on the triggers page with your VCS code. Now when you go back, where do you copy and paste your code to? You could put it here to the VCS root, but you know you're on the triggers page. You have to actually put it inside the triggers block here. So just a quick copy and paste, right? You get a compile error because there's an import missing. So let's import. And that's a tiny side note that the Kotlin DSL comes in many different versions, which don't necessarily correspond to the TeamCity server version. And 2019_2 here is the latest Kotlin code version. So you're just going to go with that. The code compiles and everything is fine again. Now let's add a completely new block. Actually, let's add a build feature. Right. So for example, let's say you want to add a build feature saying free disk space. You always want to have 6 GB of free disk space before you run a build and fail the build if you don't have that disk space. Again, do not click save, just click view DSL. Copy to clipboard, you'll see free disk space, required space equals 6 GB, failed build equals true, right? You go back, remember you're under the build features page. So inside here, you just kind of paste it anywhere, but the features block, right? Make sure you get the import right again. And that's it. So the gist is, at the beginning, when you start out with the Kotlin DSL, you're very unlikely to just go inside your settings KTS file and start writing Kotlin code. What you'd rather do is go to your TeamCity UI, change the settings, do not click save, and then just copy and paste them back into your settings KTS file. It's going to take a while. You can start out with your current project to get used to it. And after a while, after a couple of weeks, once you actually feel comfortable with all the settings and what you can specify in Kotlin code, then you would transition to writing Kotlin code, straight Kotlin code. Keep that in mind. Now, I put in all this Kotlin code, and actually for what I want to show you next, I'm just going to quickly revert it. I'm just going to roll back because I don't want my build features and my VCS trigger and whatever to be custom. I just want to have my simple build object again with the clean package goal, right? And we saw what happens when you now commit something, then TeamCity, the server, picks it up, changes the configuration. The next question is, what happens if you change a Kotlin script file here, but you also make changes in the TeamCity UI, right? So for that, let's actually go back and maybe open up the Maven build step again. And you can see on every page, literally it says, well, the configuration is now stored in Kotlin DSL. Consider changing the settings in the scripts instead of the user interface. Let's see what happens when we change stuff in the user interface. So for now, well, let's say we want to switch the goal back to clean test. And now, instead of just hitting view DSL here on the left, I want you to click save and go with the changes are not yet saved. Yes, let's save them. Right. So the build settings were updated. The goal is now clean test, so that seemed to work from the UI perspective. And when I go to my version settings, then I can see that TeamCity is actually doing something. And again, it successfully committed something to my repository. Let's see what that is. Now I'm back in my project. I'm doing a pull. And I got a file updated in one commit. I'm going to open that up here. As you can see, the goal is now Maven clean test. And I have a commit here. I'll just make that bigger, where it basically shows TeamCity was smart enough to understand, well, if you just want to change the goal from Maven clean package to Maven clean test, I can do that for you in the Kotlin code. That's pretty easy. So I'm just going to commit that change to your repo. That is quite nice. But that was a very simple change. Now, what happens if we throw off TeamCity and for whatever reason we introduce a variable, for example? So we're going to have my Maven goal in here. And this is going to be clean test. That's set to my Maven goal. I'm just going to commit and push that. And let's find out if TeamCity is smart enough to understand that variable and that now it needs to change the my Maven goal variable instead of the goal. So we're going back. we can see the latest status. So it's going to take, right? So TeamCity is now again fetching the VCS config. It's running the Kotlin DSL. While it does that, while it applies the changes, I'm already going to go to edit here, Maven clean test. I'm going to go set it back to clean package. Very confusing. I'm basically just switching back and forth between package and test here. And I'm going to click save. Build settings were updated. When I go to the version settings, again, I can see that TeamCity is doing something. It's running through my project. And hopefully, well, I see again that something was committed to my repository. Let's find out what that something was. So back in my project, I'm just doing a pull. And let's see what happens. No, the goal is still set to clean test here. But what you can see is on the left here, I got a new folder. I got a patches folder. There's one file inside, a patch for whatever the build configuration is called. It's called build here. So I get a build Kotlin script file. And this is not like a Git patch, which you can automatically merge. Rather, it's a Kotlin file you manually have to go through if you want to apply it. So in this case, you can see that TeamCity expects there to be a Maven step with the goals clean test and some runner arguments. And then the patch down here says the goal should now, everything else should stay the same, but the goal should now be clean package. And now you as a developer have to be smart enough to basically copy this or understand what is meant by this line. Go back into your settings KTS file. Now know, well, I need to change it back to clean package here, right? Like so. Or rather, let's get rid of the variable again, because it doesn't make too much sense apart from demonstrating the patching concept, right? And then you would, after finally applying your patch, you would delete your patch file again. Delete that, commit and push, and now the patch is applied. But that is a manual concept. Because TeamCity isn't smart enough, it's not an AI to understand, to fully parse your Kotlin script file and know that it now has to change the variable, right? So for simple changes, TeamCity is smart enough. For more complex changes, TeamCity cannot do much but generate these patches. Right, so that is actually the basics of how you would get started with the Kotlin DSL. So you would enable the version settings in Kotlin format. TeamCity would generate this skeleton file for you. You can play with the skeleton file yourself. Rather, you would probably use the View DSL button at the beginning, right? And try to make the changes through the Kotlin script file. But if you make changes through the UI, then you will get these commits from TeamCity. Simple changes will be directly applied. Otherwise, you'll get a patch. And that is enough to go to the next part of this live coding session, which is about building a more realistic build pipeline. Because so far, the only thing we had is we have one build configuration calling clean package. Now, with our ANU to-do list project, it's a bit artificial what we're about to do, but just imagine you're in a real-world project where you maybe have a compile step / build configuration in TeamCity speak. And then you have, because your tests are so slow and you have many of them, you might have UI tests and you might have integration tests and whatnot. You want to have some tests running in parallel after your compile step. And then at the end, you have a package step where you, well, package up your jar file, WAR file, or operating system executables and whatnot. So it's going to be a tiny build chain that runs sequentially, but also has some parallel steps inside. And we're going to start with that by just saying, well, yeah, the build type just does a Maven clean compile for now. And then at the moment, I don't want you to use best practices. I want you to repeat, well, do repeat yourself. I want myself to repeat myself. just copy and pasting code. Not the best way to do it, but for now, it's perfectly fine. So I just want to have another build configuration, which is called package. If we think about the first build step and the last build step, right? So I'm just going to go with package here. It calls Maven clean package. And then Maven specifically, clean package also runs tests. We don't want that, so we're going to use the flag skip test. So it only packages up the final jar file for our Spring Boot application. So we have these two build types, and then you would register them, the package build type, like so, with the project. Now you have two build types. You have two build types, but they are not yet a build chain. And in TeamCity speak, you know that to have a build chain, you basically need dependencies, or more specifically snapshot dependencies, between build types. Package needs a dependency on build. And in the UI, you would open up the dependencies page and then select the build snapshot dependency. So you could do the same thing in Kotlin code by just saying, well, I have one snapshot dependency referencing my build object up there. But then again, we're in Kotlin code, it's a programming language, a full-blown programming language. Isn't there a better way than having these specific snapshot dependencies, especially if we're thinking of adding more and more dependencies to our project? And yes, there is a better way. So I'm just going to comment out the dependencies block, go up to my project, and there's another method you can call in the project, which is called sequential. And the only thing the sequentials method does is, whatever build types you have in here, specified in here, they will have dependencies on each other. So the first build type won't have a dependency because there's no preceding build type, but package will have a dependency on build. And that's a very simple build chain. All you need to do. Now, before we commit this code, let's have a quick double check if everything is okay. We have our build types, dependency specified. Now, in a build chain in TeamCity, only the last part of the build chain needs a VCS trigger, so I can remove that here, right? But everything else looks perfectly fine. Let me just commit and push that code and see what happens once TeamCity sees that new Kotlin script file. Right, that worked. Let's go back. I can see I now need to wait. TeamCity was smart enough, or fast enough rather. It fetched the configuration. It's already running the DSL, right? It's going to take a second, whatnot. And once this is done here, I'm going to open up the overview page. Right, the changes have been applied. So I'm just going to go to the overview page. Let's see what happens. I can already see here that my project, a new to-do list, has on the left has these two build types now. And when I open up the build chains tab, which takes a second, I can see I have a build chain. So build is firing up, and afterwards it feeds into package. That's exactly what we wanted. Now, this is already quite cool. So we have our compile step, we have our package step, but I talked about a bit earlier about these parallel test steps. And remember, we have these two tests. We have our slow web service test, we have our syntax checker unit test. Let's make them run in parallel and put them into that build chain. Again, a bit artificial, but it will demonstrate quite nicely how you would run these parallel tests. So again, let's copy and paste and duplicate some code. This is going to be the fastest build type. It's going to be called fastest in the UI as well. We're going to run Maven clean test again. And in Maven, there's a flag saying, I only want to run classes that end with test inside of a unit package. Right. That's a flag which will run our unit test. And then I'm just going to copy and paste it again. Let's call it slow test now. Slow test. The only difference is that you now need to execute tests from the integration package, but that's all you need to do. Which means I need to go back up here, and I have to register my fast test build type and my slow test build type with the project. And I also have to put them inside of the build chain. Now, what would happen is you have your build type, then you have fast test running afterwards, slow test running afterwards, package running afterwards, because it's all sequential dependencies. So package depends on slow test depends on fast test depends on build. We want to run these two in parallel. And thankfully, there's a block called parallel, which you can call, and you just copy and paste, or cut and paste rather, your build types inside here. Now what happens is build type still has no dependencies, but everything inside, every build type inside the parallel block has a dependency on build. Package has a dependency on everything inside the parallels block. And these two don't have a dependency on each other. They will just run in parallel. That's all you need to do. So just quickly double checking again, we have our fastest slow test defined here, fast test, slow test, just calling Maven clean test. This should hopefully work. Again, let's commit and push the changes. And then wait our 5 to 10 seconds, whatnot. So the push just succeeded. Going back here to my browser, let's have a look at the status section. So this version settings tab here is basically your new friend, because you always see the current status, what's happening, that it just fetched my Kotlin script file, is it running the Kotlin script file, what is going on with my everything you'll find on the version settings page, right? So I'm just going to go here. I'm just going to refresh and see what you can actually already see. Well, I have 4 build types here. Now, what is a bit unfortunate is that the build ran while my configuration was still actually applying. This is a small bug, and it shouldn't look like this. Rather, you should have a real nice build pipeline. So we have to wait a second for it to run, actually. And I'm just going to rerun it, another run. And then hopefully in the overview, we see a nice little build chain. Let me just check. Our build chain here, right? So this is what it actually should look like if the build and the version settings aren't applied at exactly the same second. So we have our build, fastest slow test running in parallel, and our package build configuration, right? If you only have one build agent, what happens is this build chain will run sequentially. If you have 2 build agents, it's going to take a while, but then still it will run in parallel. And last but not least, you have your build configuration. Right. I'm going to wait a bit, go back to the code till this here has finished, talk a bit more about the code, and then we're going to have a look at that build chain in a second again. Because up till now, what I said is I just want to basically duplicate my code. So we simply took the build object, copy and pasted it 4 different times, just renamed a couple of settings like the name, the Maven goals, and the runner argument slightly. But everything else is pretty much the same. Now, isn't there like a better way of structuring the whole thing? And yes, there actually is a better way. You have a programming language, you can do what you want. Now, having these 4 objects that look the same, you might think, well, then let's introduce a class and call the class Maven, for example. And then cut and paste everything from inside here into the Maven class, right? And so the name differs, the goal differs, and the runner arguments differ, which might lead to you having a name constructor argument, goals constructor argument, and also runner args constructor argument. Let's give it a default value of null, so you don't always have to specify these runner arguments. And then inside here, you'll say that, well, the name should be the name. this goals should be goals. And this runner arguments should be runner arguments, like so. And now up here, you wouldn't specify the build object. You would rather go and say, well, have a new object, a Maven object, inline, so to speak. And the only thing it does is, let's call Maven clean compile, which means you can get rid of the build object for now. That works. Tiny problem is the compile error down here, because we would now need to have a reference to that Maven object up here. And I'm going to show you a better way. Instead of extracting the variable for now, I'm just going to leave in the compile error, and we're going to fix it in a couple of minutes. So for now, we replace the build type with this Maven object up here. Let's replace package, the package build type, because a package is really just Maven clean package. And here we can add the skip test parameter, the runner arguments, which means I can go and delete my package object. Just note that there's the VCS trigger inside, and we have to take care of the VCS trigger in a second as well. But for now, let's delete the object. Going up again, I have my fast test. So I'm going to call Maven clean test here. Now this time I'm just going to quickly cut and paste the runner arguments. So like so. And then last but not least, I have my slow test, where only the package differs. Right. These are the 4 build types, which means I can now go about deleting the fast test and the slow test object as well. So all I'm left with is my 4 definitions up here. I have my Maven class, and that's it. A lot less code, a lot less duplication. The only problem is I still need to define dependencies inside my sequentials block down here. And wouldn't it be cool if you could just go, well, it should ideally just be like this. So you're going to just take that like so, have that, which would be nice, but whatever you put inside the sequentials block unfortunately doesn't register with the project. So you still need to do that manually. And there's a tiny workaround. What you can do is you can ask for the build types, all the build types in the sequentials block, and then just have a good old for each loop calling the build type method with the iterator. For every build type inside here, you call the build type method on the project, and thus register the build type with the project, right? And this for loop replaces these 4 manual lines you just saw earlier. And there's one last thing we need to do is, I said the last build type of a build chain also needs a trigger. So we're just going to put our VCS trigger block to whatever the last build type in this chain is here, right? Now this code replaces all the code duplication that we just saw earlier. Let's commit and push and see what happens if this actually works, or if I missed something. Right. So I can see the push succeeded. I'm just going to go back. I'm going to go to the versions set. So actually from earlier, the build chain ran, right? Everything is green. But I just want to quickly go to the version settings page again. So TeamCity is fetching my latest Kotlin file. It's running the DSL. Now let's see if it has any complaints with my Kotlin code. Going to take a second. Again, quick breather. Right? And this is just to show you that you would also see the error message on the project's overview page. But here you see, well, I failed to apply the changes from your latest revision. It seems to me that there's, well, 3 build types with the ID a new to-do list underscore Maven. And now TeamCity says, well, it's already used in the build type. So, right, I couldn't apply your settings KTS file. Why is that? When you go back, every build type in TeamCity needs a unique ID. And if you're starting up with Kotlin code, you're going to have the project ID, so a new to-do list underscore, and then the class name from the build of the build type. The class name is called Maven, and I'm instantiating 4 Maven objects up here. So I'm going to end up with a new to-do list underscore Maven, a new to-do list underscore Maven, and so on and so forth, which is 3 times too much. And the workaround, but this is something people stumble upon, is once they start refactoring their build scripts, is you have to give every build type a unique ID. And you can do that as a quick workaround by saying that, well, I want to take the name, whatever the name that is passed in, like build fastest slowest package, and then I'm going to call the method to external ID on it, which sanitizes the value, gets rid of the white spaces and whatnot, so that it's a unique, valid TeamCity ID. So I'm just going to commit and push this change again, this time just with the ID set. Right, the push succeeded. Again, we can wait a couple of seconds till TeamCity detects the change. It's going to take us 5 seconds at least, the polling interval. And then TeamCity should fetch, as it does here, the latest revision. It's already running the latest DSL. Nice. And fingers crossed, I shouldn't get any error messages anymore. Rather, I should be greeted with, I was able to successfully apply all these changes. Right? And that's what I get. The changes were applied to the project. So I can go back to my overview page, right? The build being read was from earlier on. This was when my build was still broken. The Kotlin code was broken. So you get that fail to load build settings from VCS. But now you can see a new build is already running. And once we come back here, you'll see that everything is green again. So everything is working as expected, just with a lot less code. Now, while the build is running and while everything is turning green again, what I want to do is just quickly talk some philosophy. What you saw with the Kotlin code is you have a full-blown programming language. You have a Maven project, so you can actually include external libraries. You could also put files in here, like a JSON file, and read in a JSON file and create your build types dynamically from the JSON file. You cannot do network calls, so you cannot do like REST service calls to ask other servers because the Kotlin code is running in a sandbox. This might change in the future. I'm not 100% sure. But apart from that, you can do anything you want in these Kotlin files. And there's always a balance you have to keep between adding more custom layers on top of the default Kotlin code, because your colleagues, co-workers might not understand what's going on. And just keep that in mind. The more code you add, the more custom code you add, the harder it gets for you, potentially harder it gets for your colleagues to understand what's going on. But after a while, you should find the right balance inside your company, inside your teams, what makes sense and what doesn't make sense. Right. Now let's go back. Hopefully, this should now look a bit greener, right? So you can see the build was successful. There was one fast test passed, slow test passed, package was passed. If you want to see it as a build chain again, you can have the build chain overview. Everything is green, the test ran, and this, as I mentioned before, the red build here was when our settings Kotlin code was broken. Right, so to sum up, we had our build chain, very simple build chain. We just build at the beginning, then we had package sequential build chain with the dependency specified with the sequentials block. And then later on, we added fast test, slow test running in parallel in our sequentials block. And then we did that by duplication at the beginning. And then we refactored everything into more idiomatic Kotlin code, so to speak. Now I want to take these concepts one step further even. What I want to do is imagine, as I mentioned at the very beginning, we have a settings KTS file and it could live anywhere. It doesn't have to be in the same repository as my A new to-do list project. It could be in any repository, and I want to use that settings KTS file as a template for all of the projects in my company, because I might only have Maven projects. They always look the same. They always have these 4 steps: build, fast test, slow test, package, and whatever. So let's have some, would it be nice to have kind of a templating ability? And the only thing that differs between these different projects is, in the end, the Git repository URL. And we can actually do that with the advanced concept of context parameters. Let me show you how that works. So at the moment, we have our VCS root specified here. The shorthand I mentioned at the beginning, always the same repository as the project. Now, let's have a custom VCS root. Right? Make sure to pick the right one, the latest one. And I know that for a VCS root, I need a name in TeamCity, I need a URL, and I need to specify a branch. It could be refs heads main for now. And then I would, instead of referencing the shorthand, I would just reference the my VCS root here inside my Maven build type. And also I need to register the VCS root with the project, because it does it automatically for the shorthand, but not for custom VCS root. So I have to call the VCS root method. Now, the only thing between all these projects in my company that differs is name and URL. So we need to have some sort of a parameter in here, and that's where these context parameters come into play. You can simply go DSL context, get parameter, VCS name. Let's call it VCS name, any name you want. And for the URL, you could do VCS URL. And even for the branch, actually, let's say VCS branch, right? And let's use refs heads main as a default. Let's commit that. Commit and push. Like so. So the only thing we did is we introduced a new VCS root with a couple of context parameters, right? The question is, where do we add these context parameters now? And what I want to do is, not even as a joke, actually, I want to quickly do something before we continue. I'm actually a bit fed up with my project. I just want to delete the whole project. Let's just go, click, action, OK. Let's just delete the whole thing. So what now happened is the project is deleted, and on my overview page, you won't see any projects anymore. It's all gone. Let's try and recreate the project. So we're going to start out, forget everything, not everything you just saw. We're going to start by creating a new project. And again, I'm pasting in my repository URL, and this now should be the repository URL of your settings KTS file. It still lives inside the A new to-do list repository, but just imagine for a second, it didn't. It lived in a completely different repository, because I cannot show that or split up the repos for this talk so quickly. So this is the repo with your settings KTS file. Again, make sure to give it write access, Marco Bieler JetBrains, paste in the token, and click proceed. And now let's see what happens. TeamCity says, well, I found a settings KTS file. What do you want me to do? Should I import the settings once? So just run the Kotlin code once, that's it. Should I import the settings code and also enable synchronization? So whenever I make changes to my Kotlin code, then TeamCity updates itself. Yes, I want to do that. I'm just going to go with the project name, a new to-do list, which is fine. I'm just going to hit proceed now. Let's see what now happens. It's going to take a second. Exciting. TeamCity is now running through your Kotlin code, checking out if there's something it might not understand. And it actually does. It says, TeamCity says, well, I require the following context parameters. You need to set a VCS name. So you could just say my repo, and I need to have a VCS URL for your project, which is the same URL now, but in real life, it will be the project's URL. So I'm just going to go with a new to-do list now. I don't have to specify the branch because it has a default value. So I'm just going to hit proceed. Now TeamCity is happy enough. It has the context parameters. It will be able to run your Kotlin script file and apply the changes. And if everything works correctly, we should be greeted with our old build pipeline again, with our build chain. Let's see. So the project settings have been successfully loaded. And as you can see, our project is back again, a new to-do list. You have the 4 build types. No build is running at the moment, but I could trigger a build at any point in time, right? The build queue is running. That's as simple as it was, really. Now, a tiny thing, if you want to edit your project and you go to your version settings page, remember, I mentioned that 20 times already in this talk. You'll also find, by default, you're on the configuration tab here, where you have that current status section, where you see what TeamCity is doing with your settings KTS file. There's also a context parameters tab, where you can at any time change the parameters you just set. So my repo, for example, the VCS URL, you could also add the VCS branch, change the branch and whatnot, delete the parameter, everything you wanted to do, you'll find here under the version settings page. Right. That is, in terms of advanced concepts, Kotlin DSL wise, already enough. I don't have enough time to go into unit testing our script here, because unit testing is also something you can do with your Kotlin code. You just add JUnit, you can start write unit tests. We'll add a couple of videos in a couple of weeks which will cover unit testing. But for now, this is pretty much all I wanted to show you. Just doing a quick recap of what happened in this talk. Let me just go to logout HTML in my JetBrains to-do list application. So what we did is we started at the very beginning, we had the basic setup. So we had a very simple Maven project and created through the TeamCity UI a build configuration, right? We turned that into Kotlin code by enabling version settings. And then we noticed that, well, instead of writing Kotlin code from the start, you would rather go with the View DSL button and copy back and forth between the UI and your Kotlin code. We also saw what happened when you make changes, complex changes to your script file, but still make changes in the UI. Then TeamCity will generate patches. And then we took it one step further, looking at build chains. Very simple sequential build chain with just build, package, and then build and parallel test steps in between, and a package build configuration at the end. We refactored the whole thing because at the beginning, we did a lot of code duplication, and then we had this one Maven class at the end. And we even took it one step further at the very end, introducing context parameters in a way that you can use your settings KTS file as a template for many different projects. If that wasn't enough, you will also have further reading to do. There's the documentation, the Kotlin DSL documentation on our website. There's also a blog series from our previous developer advocate, Configuration as Code, a 6-part series, a great series on how to get started with Kotlin code in TeamCity. And we'll paste these links also in the chat in a second, I think. But other than that, that was all I wanted to show you. I hope you learned something from the talk. And that's it from me for now. Thank you.
Great. Thank you so much, Marco. Really helpful talk. And I'm seeing a lot of our TeamCity customers, and really across the CI spectrum, whether you're using TeamCity or one of our competitors' tools, customers are moving towards configuration as code. So if it's not something you've encountered yet in your own environments, I expect this is something you're going to encounter in the next 1 year, 2 years, as more organizations look to take advantage of a lot of the functionality that versioning your configuration settings can offer. We'll ask a couple questions and then we'll get moving on with our next talk. Marco, could you speak, I guess, a little bit generally, keeping on that same point, to why some customers are moving towards configuration as code and some of the benefits it offers?
Right. I mean, it's just you have everything traceable in one repository. You can see who changed what. You can always roll back to a specific set of code, basically. You can, if you're using Kotlin or any other programming language for that matter to write your configuration, you have all these refactoring possibilities. What we did is not just like, well, with XML or YAML, the YAML hell, where you have very, let's say, basic capabilities of creating complex build pipelines, for example. With code, it's pretty much up for you to decide what you want to do, how you want to do it, and it's just really powerful. So I think that combination between having Kotlin code, the power of Kotlin, and then having everything in a central repository, traceable version at all times, it's a very good combination that you might want to check out for your build systems.
Yep. Yeah, completely agree. There are also a number of questions in the chat about being able to lock down the user interface. So I'll address a couple of those questions. Right now, you can set your TeamCity server into a read-only mode so that you can't make configuration changes to your build config. So that's one way to prevent users, at least from going into the UI and modifying changes. We will introduce some more functionality in some of the 2021 releases that will further help you lock down your TeamCity instance if you want to move to an environment where all of your configurations are defined as code. The last thing is you can manage the roles, basic roles in TeamCity, so you can prevent users from accessing the build configurations or being able to edit there. Let's see. One of the questions in the chat, how is it recommended to test your DSL changes in TeamCity? And I know we addressed this in the chat as well. So Marco, you mentioned unit tests. Could you talk a little bit about some of the basic capabilities there?
Right. So basically what you can do is, as I mentioned, you can add any library you want, your JUnit, for example, TestNG, whatever. Start writing unit tests and testing your configuration so that every, for example, build type has a specific requirement on a specific Java agent version that your project has maybe in build step and whatever you basically wanted to test. And what makes sense then actually is to run those unit tests as part of your build chain as a very first step. So you could essentially just say you have one build configuration at the very beginning of your build chain running through these unit tests. So you always are sure that, well, you have the chain in an expected state, your build configuration in an expected state. That's how we would approach it. But then again, it takes a couple of minutes to show it. A bit too many minutes for this talk. But we're going to publish some material. And also in the blog series I mentioned, you will find a unit testing example you can try out yourself.
Yeah, great. Excellent. And this is an area we've identified internally as a topic a lot of people want to learn more about. So if you're asking where certain documentation is, we really do appreciate that feedback. Sometimes the squeaky wheel gets the grease. So make sure you're tweeting at us on our U-Track, yelling at our great support engineers that this is the type of content you want, and we'll do our best to put it out there for it. All right, Marco, I think that's all I'm going to ask of you today. We're certainly going to ask plenty more of you over the weeks and months to come. So we appreciate your time.
Cool. Thank you.